Wow, can you really build a humanoid robot with just $4,000? Surprisingly, yes. This is the Berkeley Humanoid Lite, designed by the University of California, Berkeley, a fully open source humanoid robot. It stands 80 centimeters tall, weighs 16 kilograms, and has 24 degrees of freedom. It can walk, coordinate both arms, and even learn movements in simulation before transferring them into the real world. Isn't that amazing? And not only that, it can also be teleoperated, write, stack blocks, you name it. The best part? Everything from the 3D models to the actuators to the control code is open sourced on GitHub. Now, you might ask, aren't there already humanoid robots out there? Of course, but here's the catch. They are either extremely expensive, costing tens or even hundreds of thousands of dollars, or completely closed source, meaning you can't modify them, or they're so tiny, they're more like toys. The Berkeley team had one very clear mission: build a humanoid robot that is affordable, hackable, and can actually walk. So how did they do it at such a low cost? Most of the body parts, like the arms and legs, can be printed on a desktop FDM 3D printer. The main frame is built from simple aluminum profiles. This alone drives the cost down significantly. But if we look at the bill of materials, one fact jumps out immediately. The most expensive parts are the joint actuators that make up about 80% of the total cost. Two versions of these actuators cost about 136 and 188 US dollars each. And note, this is not just the motor alone. It includes the motor, the gearbox, and a 3D printed housing, altogether as one complete actuator. Compare this to conventional humanoid robots, where a single actuator can cost hundreds of dollars. Wow, what a difference! So how is this possible? The secret lies in their custom-designed cycloidal gear reducer. This design can be manufactured directly with a desktop 3D printer, removing the need for expensive machining and procurement. This is the real reason why the cost of this humanoid can be so low. But now you may wonder, are 3D printed gearboxes actually reliable? Let's take a closer look. The Berkeley team chose a cycloidal gear design, which works very differently from the more common planetary or harmonic drives. Instead of one-to-one gear tooth engagement, here we have an eccentric shaft driving a disc inside a gear ring. The edge of the disc makes contact with rolling pins, so multiple teeth are engaging the inner ring at the same time. Take a look at this exploded diagram. The green part is the input shaft, driving the yellow cycloidal disc in an eccentric rotation. The outer edge of the disc engages with the white rollers and multiple points. Finally, the motion is transferred to the purple output shaft through pins. Isn't that beautiful? And why use a cycloidal gear instead of traditional planetary or harmonic drives? Because planetary and harmonic drives rely on involute gears, which are terrible for desktop 3D printing. Even tiny burns can lead to poor meshing or gear failure under load. Cycloidal gears, on the other hand, have smoother profiles, distribute the load across multiple points, and are far more tolerant to printing errors. Perfect for 3D printing. At the same time, they provide high load capacity, low backlash, and huge reduction ratios. A single stage can reach over 100, and a double stage can even go to in thousands, all in a compact package. Absolutely incredible. Of course, it's not all perfect. The eccentric motion introduces extra vibration, and because there are so many contact points, friction is higher. This means the efficiency is lower than precision machined gears, but still, the numbers are stunning. The paper reports that in most cases, the mechanical efficiency is above 90%. And after 60 hours of continuous operation, the actuators showed no failure. For a low-cost, open-source humanoid robot, that is really impressive. And so, this is how the team brought the cost of a humanoid robot down to just $4,000. 3D printing for the structure, and custom cycloidal gear actuators for the joints. Wow, just wow. Would you like to build your own humanoid too? If you enjoyed this, don't forget to like and subscribe so you won't miss more amazing robotics.